do tell me if my voice is clear to you or not, and if the screen is visible or not.
Yes, sir.
All right, all right. Okay, okay then.
So yes, screen is visible.
It is visible. Okay then. Okay, so before we discuss about that, I have got few questions for you, and one more thing. Just have a look at this chart where calorific value of different fuels are given here. See here, this table here. See, the fuel having least calorific value is a cow dung cake, right? Here in India, cow dung cakes are used as fuel in villages, right? Then you have wood, coal, biogas. See, the calorific value of a cow dung cake is around 6,000 to 8,000 kilojoule per kilogram. All right. And see the fuel hydrogen gas. It is having a calorific value of how much? 1,50,000 kilojoule. So remember,
So what is kilojoules?
kilojoules. Look, joule is the unit of heat, right? You measure heat in what? We know we basically measure heat in joule. So 1 kilojoule means 1,000 joule, right? That's just a bigger unit of joule. Got it, right? Yes, Aran.
What's sir?
Am I not audible?
No, sir, you are.
Yeah. So I'm saying that joule is the unit of heat. Joule is the unit of heat. Okay. So joule heat is measured in joule, and higher quantity of heat is measured in kilojoule. Right, guys? It is measured in kilojoule. Okay. So if you have got 1,000 joule, in short, you will call it as 1 kilojoule. Got it now?
Yes,
So
sir.
see here, these are the fuels and their calorific values are given here. All right. Okay, then. So quickly, let's solve few questions and then we will start discussing about flame. See here, question number 56 here. Which of the following substances has the lowest ignition temperature out of kerosene, spirit, diesel, and mustard oil? Yes.
Sir, kerosene.
Kerosene has the lowest ignition temperature. What about spirit? And what do you think? Which of this substance has got the lowest ignition
Sir,
temperature?
was is kind of light.
Sir, ignition, sir, mustard oil.
No, it's spirit here. The ignition temperature of spirit is lowest, right?
Okay, sir.
Now, see second question. One of the following is not a combustible substance. This one is. Yes. See the options. Yeah. What are abastos, by the way, in this question? Yes, Ahmad and Arhan, do tell me. Abastos, simply they are a group of naturally occurring fibrous minerals. Okay, and they are, look, I'm writing its property. Don't need to go in depth about this substance. Just know that it is a naturally occurring fibrous substance and it is resistant to heat. Okay, so obviously one of the following, the question is one of the following is not a combustible substance. So since it is resistant to heat, it will not be a combustible substance, asbestos. While chaff, hydrogen, and alcohol. These are combustible substances. Okay. So I told you the answer of this question because the term was not familiar to you guys. See this question.
Excuse me, sir. We cannot hear your voice.
Okay, I'm not audible.
Now, sir, you
Okay.
are.
Just actually the problem is no though my I have got some issues in my network connection today. That's why it's becoming late, you guys. Okay, so please adjust for today. Yeah. So see question number 58.
Question number 58. Which of the
Sir,
following
the
is not?
answer is white forest. Phosphorus.
Yes, Ahmed, that is correct.
Yes, sir, it is, I guess.
Yeah. Answer is correct. White phosphorus. Remember, we discussed this in previous class that on the matchbox, the strips consist of white phosphorus. Okay. Actually, they are made up of red phosphorus, but upon ignition, they convert into white phosphorus. Right, guys? Okay. See next question.
Sir, a brown sulfur.
Sir, it's
No, we did not
red
even discuss
phosphorus.
about brown sulfur.
Sir, it's red phosphorus.
No. It's white
Since
phosphorus again. No, no, guys. It's white phosphorus again here. Look, if you guys remember, yeah, if you guys remember the burning of a matchstick, look here. This is made up of white phosphorus. See this figure here? The strip is made up of red phosphorus. It is made up of red phosphorus. Okay. Now, in the older times, in the older times, white phosphorus was being used, but it was harmful. So it was replaced with red phosphorus. And upon ignition, this red phosphorus, it converted to white phosphorus. Okay. And that white phosphorus was responsible for ignition. If you guys remember, white phosphorus was actually responsible for ignition. So for spontaneous combustion, white phosphorus was responsible. So answers option C is the right answer. Got this one.
Yes, sir.
Next question. Yeah, one of you read the question.
Which of the following statement is not correct about carbon dioxide acting as fire extinguisher for electric fires? Um, it is
sir,
lighter than air.
sir, it's heavier than
It's
air.
no. The statement it is heavier than air, that is correct. The statement it is lighter than air, that is false here. Okay. So option B is the right answer because the question is asking which statement is not correct. So we know that
Yes.
it is heavier than air. It forms a blanket of gas over the fire. Okay. And it replaces the lighter air. It is
Yes, sir.
not combustible. We know that carbon dioxide, neither it supports combustion, neither it burns itself.
Yes, sir.
Okay. And we know it does not support combustion. So option B is the right answer. Next question.
Fire is fire in underground coal mines usually occur due to the rapidly combustion. Rapid combustion.
No, look, there are no two types of combustion. Okay.
Sir,
One will be
explosive combustion.
No,
or
explosive combustion. No, that is also not the answer.
conscious? Conscious?
Usually, fires in spontaneous. Right. Okay.
Yes, sir.
Guess is correct. Look, usually under the mines, fire that occurs, it is not triggered by some rapid action. It causes fire on its own. Okay.
Oh,
Right. So there's a
yes.
spontaneous combustion happening in there. All right, guys. So suppose
Yes.
if the pressure is too much in there and if there is too much heat in there will be a spontaneous combustion. Because coals are also different kinds and different types of coals have got different ignition temperature. Okay, so if let's say there are some type of coal found in underground mines which have got a lower ignition temperature. So if that ignition temperature is achieved, that coal will caught fire. Now, the calorific value of a fuel is how much? 40,000 kilojoule per kilogram. This fuel is most likely to be.
Sir, LPG.
Yeah.
Sir, LPG.
No, it's not LPG. No, 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 no. For that purpose, no, you guys need to memorize some of the calorific values of some fuels.
Hydrogen gas, sir.
See if no, if you guys see this biogas here, what is the calorific value here? Between 35,000 to 40,000 kilojoule per kilogram,
Yes.
right, guys?
Yes.
So that is answer. So you guys do one thing, no? Remember calorific value of biogas, petrol, LPG, and hydrogen gas at least. Okay, so that you guys can quote some examples in your answers in your exam. That will fetch you more marks, right, guys? So whenever
Yes,
you
sir.
answer some questions, try to put in some examples in your questions. Okay, now next question. Let's quickly get done with it since we have to cover flame also today. 63 question. What does it says?
Which of the following fuel has the highest calorific value?
Yeah. So
Sir,
the
it's
answer is
LPG.
no, 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 no. Farhan, if you remember, the fuel in the last in the table was hydrogen gas. All right, 1,50,000 kilojoule per kilogram was 1,50,000 kilojoule per kilogram. So that was the highest calorific value. So remember, out of all the fuels, hydrogen gas has got the highest calorific value. Okay. Now, next question says, on a cold winter night, the person sleeping in a room with closed door and windows with a coal fire burning inside may die to the excessive accumulation of. We know that when you
Sir,
burn
carbon
coal,
monoxide.
carbon monoxide. Very good. Carbon monoxide, or yeah, that is option D, right? Carbon monoxide. Okay. What is its formula? Capital C and capital O. Okay, that is carbon monoxide. Which of the following burns without producing a flame? So that we will discuss when we will talk about flame. See question number 66.
Sir, 60.
Yeah.
You missed one question.
No, I'm since this question consists flame in it, it talks about flame. We haven't yet talked about flame. So leave it then. Okay.
Oh.
But still the answer is going to be coke here. Okay. See next question. Which fuel has lowest calorific value?
Sir,
Which
No, no. We had cow dung. Okay. Then we had wood. Then we had coal. Then we had biogas, if I'm not wrong, right, guys? Then after all these fuels came, so biogas, out of all this, biogas has got lowest calorific value out of all these four. Next question.
Oh.
What is the answer?
The carbon
Sir,
dioxide.
Yeah. Yes, Simon? That is carbon dioxide. Okay. Which of the following gas does not contribute to the formation of acid rain? So that we will also talk in today's class. Okay. Okay. Next question is, which of the following is the most environment friendly fuel to be used in automobiles? Question number 69. See this one.
The natural gas.
Natural gas. Very good. Yes. Last question. Which of the following does not involve a combustion reaction? Read the options carefully. In fact, Ahmed, I posed this question to you while Arhan was absent in the
uh,
first class. So I posed this question to you.
uh, sir, C.
Exactly. Yes, Ahmed, do you agree with Arhan? Do you agree with Ahmed's answer?
Yes.
Yeah, very good. So it is option number C. Okay, because what happens? Nuclear fission happens there. Hydrogen gets split into two helium in this one. So that is not a combustion reaction. Now let's start the topic. Candle flame, that is our topic, right, guys? Okay. So if you see any clean fuel burning, okay, what are the examples of clean fuel? Like, let's say you have got LPG. Okay. So whenever you will burn LPG, liquefied petroleum gas, you will observe a flame. And when you will burn, let's say, a candle or a kerosene lamp, okay, there we will also observe that it burns while producing a flame, right, guys? Also,
Yes.
if you guys burn a magnesium ribbon, okay, that also gives off a very sparkling light, right, guys?
Yes.
So whenever you see construction work is going somewhere where iron is involved, they join two irons using magnesium ribbon. Getting it? Okay, so there you must have observed very sparkling light is coming from that burning magnesium ribbon. So for the generation of fire, we know that we generally need three things. We need heat, we need oxygen, and we need fuel. Okay. So, but the question is that what is this flame now? So flame is basically a region where combustion or burning of gaseous substances takes place. Okay, suppose you have got a candle here. Okay, guys. So candle is made up of basically paraffin wax, right? We talked about paraffin wax in the previous chapter.
Yes.
Paraffin wax comes from it comes from distillation of petrol,
Yes, sir.
right, guys? So when you burn it, what happens? This solid paraffin wax gets converted into vapor when it burns, gets converted into vapor, that is in gaseous form. So this gaseous form burns with a flame here. This gas of paraffin wax burns with flame. Okay. So this flame is basically that region where combustion of gaseous substance takes place. Right, guys? Getting it what I'm trying to say?
Yes.
I'm saying basically that the solid fuel got converted into vapor state, and it's the vapor state that produces flame on burning. Right, guys?
So, sir, paraffin wax is also
Okay.
flammable.
Yeah, paraffin wax is also flammable. Okay, so you will see all the gases which undergoes combustion, they will produce flame. Okay, but the thing is that only those solid and liquid fuels which vaporize on being heated burn with a flame. The condition is that the fuel I am burning, whether it's a solid fuel or whether it's a liquid fuel. Okay, if they vaporize on being heated, only then it will give you a candle flame. For example, if you burn a coal, if you burn a coal, does it gives a flame?
Yes.
No. If you burn a candle and if you burn a coal, coal just glows. Coal does not burn. It just glows. I mean, coal does not burn by producing a flame. It just glows. Right, guys? So we say that the reason here is that why coal is not producing flame, because coal does not get converted into vapor state. Get this thing very clear, guys, that only those solid and liquid fuels which vaporize on being heated, they will burn with a flame. Did you guys got this one thing
Yes,
or not?
sir.
Ahmed, you?
Yes, sir.
Yes, sir, I have also got it.
Very good then. Okay. So let's say we have got LPG and biogas. These are gases which also undergoes combustion. So LPG and biogas will burn by producing a flame. Some other examples are like wax and camphor. They are what? They are solid substances which also vaporizes on heating. So whether you have wax or camphor, they will also burn with a flame. Similarly, you have kerosene oil, you have mustard oil, you have kerosene oil, you have mustard oil, sarson ka tel, right? You have got mustard oil. They will also burn with a flame because they produce vapors on being heated. So some of the substances which burns by producing flames are what? As I gave you guys example, they are LPG. You guys give more examples. It will biogas,
The natural gas.
Sir,
natural gas.
CNG.
Yeah, that is CNG or natural gas. Both are same
LP.
things.
Sir, coal gas.
LPG, coal gas. Okay, we can take that.
And
Kerosene oil. You can take liquid fuels as well. Kerosene oil.
The petrol.
Yeah, we have taken petrol. Okay, you can take petrol also. Liquid petrol. Mustard oil. Right, guys. So that's enough examples of fuels which burns by producing flame. Okay. So you see the wax candle, like for example, this one here, a wax candle or a kerosene oil lamp. They have got wicks in them, like this thread running in them. So it is a thread that basically burns. Okay, that is on fire, and due to the heat of this wick, due to the heat produced, it melts the paraffin wax. So it converts solid into vapor here. So it's the vapor that is burning, right, guys? Okay. So let's take an example of charcoal and coal. What is the case with them? You see, charcoal is a solid fuel, and the thing is that it does not vaporize on heating, right, guys? So will charcoal produce a flame?
No, sir.
Yeah. So let me write one statement here. Only those liquid and solid fuels which have you guys been taking notes of class or not?
Can I do them after the chapter is finished?
Okay, that is good. Okay, or for reference, if you guys would like, I can share the PPT with you guys as well. Okay. So only those liquid and solid fuels which forms gases on being burned gives a flame. Right? So remember this thing. So a charcoal, just give me a minute. Yeah. So a charcoal, it will not give flame. Why? Because it does not vaporize. Now what about coal?
So it also does not give flame.
Exactly. Right, guys. So coal will just glow red on combustion. Okay. Now, whenever you burn any type of fuel, the type of flame produced depends on the proportion of or the amount of oxygen which is available to the fuel. Right, guys? Like all flames are not of same color. If you see LPG gases when they burn, their color is different. Or if you have got a kerosene lamp, if you burn it, or if you have got a candle, the color of the
Yes,
flame differs, isn't it? Yeah. And Ahmed, yeah, that is the case.
Yes, sir.
Yes. So let's first see the zones of a candle flame. Okay, we will. Yeah. Am I audible?
A little bit, sir.
Okay. Am I audible now?
Yes, sir.
Yeah. So you see, the thing is that the type of flame which is being produced, it will depend upon the amount of oxygen supply. Okay. So there are three cases here. Before we discuss that, let's first now quickly get done with this zones of candle flame. Okay. Let me just add one more slide in here, right, guys, so it becomes convenient. Yes. So I was saying that when fuel burns, do tell me when if my voice is audible. When do tell me if my voice goes away. Okay.
Okay, sir.
When fuel burns, the type of flame produced depends upon following factors. So the first factor, na guys, it is availability of air. Availability of air, or we mean oxygen supply. Okay. So if the air is insufficient, the candle will give a yellow flame, or the fuel will give a yellow flame. If air is insufficient, yellow flame will be seen. Getting it? You guys can relate with it. As if you see a candle is burning and that gives you a yellow flame, it means the candle is not getting enough oxygen. Right, guys?
Yes.
And see this thing here. Okay. Now the thing is why we are getting a yellow flame here. What is the reason behind this? The reason behind this is that you see this wick which is burning, it must also be producing carbon particles upon burning, since it is made up of carbon basically. All right, it is basically the thread. Okay, so the carbon particles, if there are some unburned carbon particles, if there are some unburned unburned carbon particles. Okay, so then you will observe a yellow flame. Okay, so basically yellow flame is caused by the glow of unburned carbon particles. Why there are unburned carbon particles? Because complete combustion is not happening here. So there is incomplete combustion here. So if there is incomplete combustion, okay, then you will get a yellow flame.
Yes,
And where is this yellow flame coming from? It is basically the glow of hot unburnt carbon particles. Aran and Ahmad, did you got this one?
not.
Yeah.
I didn't got it. That I didn't understand it, sir.
Okay, look. Okay. Ahmad, my voice is coming properly to you?
Yes, sir. Your voice is coming. Sometimes it's like okay, and then it bugs. Sir. It's like,
All right. Look, the thing is here that this wick, that is thread, when the candle is not burning properly, okay, if the oxygen supply is insufficient, then the fuel, that is this paraffin wax, will not burn properly, right guys?
yes, sir.
So this will give off a yellow flame. The reason why you guys see a yellow flame is because of the glow of hot unburnt carbon particles. So the carbon particles which are coming off this thread, they are unburned. Okay, they are not completely burnt, right guys? So it is due to those unburned carbon particles you guys see a yellow flame. So those unburned carbon particles na, are glowing. Okay, although they have not burnt completely, but they glow, right guys? So let's say if you place a paper over it, not too close, okay, if you place a paper or any metal or any other object over it, you will see that a blackish layer of